An isolated tribe in Africa has a total population of 8,000 individuals. Of these, 26 individuals are albinos, so it's a recessive disorder. And assuming that this population is in Hardy-Weinberg equilibrium, what is the percentage of the population that is a carrier for albinoism? And so basically, how many individuals of the 8,000 are carriers? We want to know that as well. So to solve this, first thing we have to do is we have to find the frequency of those alleles. So albinos, they would be, it's a recessive disorder, so those would be little a, and we have 26 out of 8,000 individuals total that actually have that. So if we want to know the frequency of little a, we would have to divide that out. So if we do that, we have 26 divided by 8,000, and we get a frequency of 0.00325. Okay, or in other words, this would be 0.32%. And so remember that this really represents Q squared, and if the homozygous recessive is Q squared and we want to solve for Q, if we know, if I just rewrite it right here, we want to solve for Q, we've got to take the square root of both sides. So Q is going to be equal to 0.057. So that's our Q. If we want to solve for P, remember that P plus Q equals 1. So we know that P plus 0.057 is going to be equal to 1. So that makes P equal to 0.943. Once we know that, we can solve for the carriers. Remember that carriers are heterozygous. That's an important thing to remember right here. So heterozygous individuals are represented by 2PQ. So to solve that, we would take 2 times the frequency of P, which we solved down here to be 0.943, times the frequency of Q, which is 0.057. So if we solve that, we get a carrier frequency or heterozygous individual frequency of 0.10, I'm going to round it to 108. So 10.8% essentially. So if we want to know the percentage of the population that's a carrier, and we're asked for it in a percent here, so we are going to convert it to percent, that's the frequency. If we want to know how many actual individuals of our 8,000 are carriers, we would just take the 8,000 and we'd multiply it by the 10.8%. And so if we multiplied that times 10.8%, and remember that if you're punching this into the calculator, it's really easier to use the decimal version. So I'm just going to go 8,000 times 0.108, and we end up with 864 individuals that would actually be carriers for albinoism.